Okay, so if you have an organic unit test coming up, here's a great review to go over. It's all old diploma questions from the Alberta diploma. So starting with the very first question, it's asking, in comparison to inorganic compounds, there are many organic compounds, which are the following statements would best explain why carbon forms the basis of so many compounds. So the first one is talking about carbon having a high electronegativity. The second one, carbon atoms combine easily with hydrogen. C, they readily form covalent bonds with other carbon atoms. And lastly, they readily form many strong ionic bonds with carbon atoms. So going through this, just a few things. They do combine easily with hydrogen, but that's not so much what makes it organic. They don't have a high electronegativity. And this last one, they do not make ionic bonds because that would mean there's a metal present, and that's inorganic. So the best answer here is C. Number 2 is asking for the empirical formula for 2,4-dimethyl cyclopentanol. So I think this one, it's helpful just to draw it out. So you have a ring of 5 carbons. Because it ends in OL, there's an alcohol, and that would be assumed to be on carbon 1, and you can put it wherever you want and then start numbering your carbons. So if this was my carbon 1 and I went clockwise, then I would have carbon 2 and, not there, on carbon 4, I have a methyl group, and then I can count my hydrogens. So I definitely have 5 carbons, 1 oxygen, and once I count all of my hydrogens, so 1 here, there would be 1 on this carbon, there would be 1 here, 2 here, 1 here, 3 on the methyl groups, and 2 up there. So once you add those all together, you get 14 hydrogens. So this answer would be C. Moving down to the numerical response question, in order from the compound that has the highest melting point to the lowest. So they all are esters. So looking at this, it's just the biggest one would have the highest melting point. So your biggest one is the last one, and then as they get smaller, the melting point would get lower. So this would just be 4, 3, 2, 1. How are they classified? They definitely are esters, and there are no benzene rings, so they're not aromatic. They'll be aliphatic, or aliphatic. So we're say that this is A. Number 5, which of the following names is correct? I find with this one, it's helpful if you don't see it right away, then to draw it. So like this very first one, it says 2,2,3-dimethyl. Already, if there are 3 placements, this should say tri. So we know it's not going to be A. If I was to draw a 2,4-diethyl octane, I would just do a quick line diagram. So 1 carbon here, 2, 3, 4, 5, 6, 7, 8. On carbon 2, I want to put an ethyl group, and on carbon 4, 1, 2, 3, 4. So when I do that and I count my carbons, my longest chain now would actually be starting at this carbon. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the mistake here was octane. And then you can keep going from there. If we draw out 5C, we have 3-ethyl 2-methyl heptane. So drawing that out, heptane, 7 carbons, 1, 2, 3, 4, 5, 6, 7. On carbon 3, you have an ethyl group, and on carbon 2, you have a methyl group. So I don't see any mistakes here. We can try the last one just to make sure, but the last one is the one that's wrong. So C is the right answer. Moving on from here, looking at isomers, going through that. Same idea. If you can tell right away, great. If you can't, draw it out. So the first one, if I drew out hex 2-ene, hex would be 6 carbons. So 1, 2, 3, 4, 5, 6. On carbon 2, you have that double bond, and then count your hydrogens. So this would be your 6 carbons, and then we have 3 here, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this first one works, and that's what we're going through. Just drawing them all out and seeing which ones would follow 6 carbons, 12 hydrogens. So going through it, number 2 will work. Number 3 does not. Number 4 does work. Number 5 does not. And number 6 does work. Number 7 does not. So if you were looking at this one, it would be 1, 2, 4, 6. But yes, just draw them all out and confirm. Like if I just looked at that last one, 3,3-dimethyl but1-ine. So but would be 4 carbons. On carbon 1, you have your triple bond. On carbon 3, you have methyl groups. So we can count our carbons, there's 6 of them. Count your hydrogens. On the end here, you'd have 1. Here you'd have none. Here you'd have none. Then you would have 3 here, 3 here, 3 here. So 3, 4, 5, 6, 7, 8, 9. Oh wait, I made a mistake here. 1, 2, 3, 4. Oh, yeah, this isn't one. Good thing I checked that. That is not one. It was, oh, that, okay, perfect. It wasn't one. I didn't even have it listed. So just going through it, it didn't have enough hydrogens. All right, so looking at this next one, that didn't transfer over the best, but when we're looking at this, I'm wondering if it will catch up here. Maybe not. Okay, so it's asking which ones would describe the structure of 1,2-dichlorobenzene. So that would be this first one, because we have that alternating double bond and we have those chloral groups on there. So it would be number 1, and then I know we can't see the rest, but I can tell you what it said. So between 3 and 4, you would be deciding between aliphatic and aromatic. So 4 would have said aromatic, so that's why we would pick that. And then 5 and 6 are asking between saturated and unsaturated. So because we have that double bond in there in general, it's going to be unsaturated. And then the last part is identifying that there is a halide group on there, and that's what this one would have said. So that would just been 7. So sorry about the formatting here, but that is what it's asking, just being able to tell the difference. And then the last 3 choices here were alcohol, which we don't see, acid, which we don't see, and ester, which we don't see. And so that's why we had that halide choice up here. So moving on from here, question number 8, we're asked to correctly name the following. So we do know you want to pick your longest chain that contains the double bond and give it the smallest number possible. So I'm numbering from right to left to have my double bond between 1 and 2. Then I notice I have a propyl group, I have an ethyl group, and I have a methyl group. Then it's just about naming alphabetically. So when you want to name in order here, you want E, and then M, and then P. So naming those, this ends up being 3 ethyl, 5 methyl, 3 propyl, hex, 1 ene. Okay, question number 9. Again, we're missing a little bit of the diagram, but I think we can figure it out. Which of the following is both aliphatic and unsaturated? So aliphatic, you do not want to see a benzene ring, and unsaturated, you want to see a double bond. So here the best answer is B, because we do have a double bond within our chain. Number 10, which shows an ester as a functional group. So this first one is just an acid. That's just an alcohol. So coming over here, we do have the ester link. It's right here because we're looking for your carbon double bonded to an oxygen, single bonded to an oxygen, and then you have your carbon chains, or just over here it could be hydrogen, but this has to be a carbon. So that's the only one we're seeing. So C is not one because we had to have seen an oxygen connected at some point, which you don't have. So that one was D. Question 11, naming this correctly. So we would want to identify that this is a carboxylic acid. We want to also remember that your carboxylic acid always contains carbon 1. So 2, 3, 4, 5, and 6 is your longest chain. So on carbon 2, you have an ethyl group, and then 4, 5, you have a methyl group. So it looks like the answer for this first one is going to be A. Moving down from here, the same thing's happening. So we have our structure, and then this is C6H11 and then Cl. I think that's going to come in handy when it's looking for isomers, which kind of means we can't do one of these questions because we can't see it. But this first one, structures and descriptions, and then they're asking which ones are isomers. So we would have went through here and seen which ones actually line up to this, but I don't think there's a point in showing it since we can't see all the structures. So let's just keep going here. Question number 13. In comparison to their alkane derivative, which property is true of small chain alcohols? So what this means is if you have a carbon atom, so say this one was ethane, and then you had compare it to carbon atom, but it has an alcohol group, we want to know what's the difference between these two. So alcohols would be more polar, and they would dissolve in polar solvents. Alcohols also would have a higher boiling point because they have hydrogen bonding, so more forces to break. So when we're looking over answers, it looks like the best one is A. So going through it, more soluble in nonpolar. Well, that's not true because you have to dissolve in the same. Less soluble in polar solvents. That's not true. It would be more soluble. It would have higher, and so that's the only one that worked out for us. Question 14, another naming one where you just want to contain the triple bond in our longest chain. So I'm going to start numbering from the top here. So 1, 2, 3, 4, 5, 6, 7, 8. So that reminder that when you're looking at a line diagram, triple bond is linear. Some line diagrams will show that. So you just want to make sure to put carbons beside each of them and then keep counting. Then when we're looking at it, it looks like we only have that we have an methyl group on carbon 2 and on carbon 6. So this would be 2,6-dimethyl oct 3-ine for where our triple bond was placed. Similar, another naming question. Numbering your carbons. Again, start on the side. That will give you the lowest number possible on the double bond, and then find your longest chain. So this one will be our 3,4-dimethyl hex 2-ene. The next one, finding your carboxylic acid. So carboxylic acid ends in COOH, right? Because we have that carboxyl group that we're looking for, and that would be B. Number 17, which of the following represents 1,3-dimethylbenzene? So if you have a benzene ring, we have to start at any point here with your carbons. So say I said this was carbon 1, that would make this one carbon 2, so that's not 1 and 3. If I looked at this next one, this was carbon 1, 2, 3, that's going to work. This one shows are both on 1. Ooh, excuse me. And then this last one is putting it on a number too far away. So the answer is B. Okay, so now we have this example here, and that question is asking to identify which ones are an ester. So if I was looking here, so esters again have that chain that is going to be from the carboxylic acid. So C double bonded O, single bonded to another O, and then some more carbons. So we're looking for this link here. So that would be number 3 here and number 5. It would not be number 6 because the ending here shows it's just carboxylic acid. So that would be 3 and 5. The next one is asking which structure represents 2,2,4-trimethylhexane. So looking at this one, if I was looking for 2,2,4-trimethyl, I want to see 3 methyl groups on your longest chain, which is going to be 6, 3, 4, 5, 6. So that answer was 9. And number 20, which molecule would turn blue litmus paper red and react with compound 4 to produce an ester? So this way, the way it's asking is looking for an acid in particular to react with an ester or make an ester. You're looking for your carboxylic acid. So that would be showing number 3. And then moving on to some more naming, but now with a halide. We want to still number our carbons to give the lowest number with that double bond. And then we have on carbon 3 a bromine group. So this would be 3 propene. So we're going to pick B because we only have that spot. I would have preferred for them to have 3 prop1ene, but process of elimination would have to pick this because the other ones don't work. Correct name, once again, we want to number our carbons. If you have a double bond on your ring, it's always between 1 and 2. So I'm going to start this one as 1 and this one as 2 to give the next priority, the methyl group, the smallest number possible. So my double bond is between 1 and 2, and then methyl is on 3, and then 4, 5, 6. Because it's a ring, you must see the word cyclo. So this is 3-methyl cyclohexene. 24 is a theory question. Did I skip one? Oh, sorry. 23. Which one is not an alcohol? To be an alcohol, you must have a carbon attached to an OH group. So we have this one is an alcohol, alcohol, alcohol. This one, that looks weird. This one is not, and that's because this part here is not attached to our carbon off the main chain. 24, organic compounds that are primarily non-polar and exhibit weak intermolecular forces. So if you're non-polar, you're probably an alkane, or alkyne. And if you only have, or if you have weak forces, you probably only have LDF. So in that case, they would have low boiling points. They wouldn't have strong aromas because that indicates a benzene ring, which would increase that. No high solubility because you would need something polar, and no high melting points because you don't have that many forces. Number 25, when comparing strengths of intermolecular bonds, hydrogen bonding is most noticeable in. To have hydrogen bonding, you need an oxygen directly bonded to a hydrogen, a nitrogen, or a fluorine. So with that, it's not going to be aromatics. That's just saying we have a benzene ring. We don't even know if we'll have oxygen there. Esters, we don't have that direct bond of the OH group. Alkanes wouldn't have an OH on it, so the best answer is B. 26 is talking about a homologous series. If you have a homologous series, you are just increasing or decreasing in one carbon. So it's not going to be the first one because they stay the same. It's not going to be the second one because they're not increasing in a nice order. It's not going to be this one because same thing, carbons aren't increasing. So it's only D is possible. So C2, C3, C4, and we can take a look and see that they're all in the same family. Question number 27, asking which one is an isomer. Again, isomer, if you take a look, you would have the exact same number of carbons, the exact same number of oxygens, and the exact same number of hydrogens. 3, 4, 5, 6. So if you went through each of your choices here and counted, the only one that matches is B. General formula for an alkane series. I would say just if you know the formula, great, you would recognize it to be C. If not, draw an alkane and see which one matches, and you would figure out it was C. Number 29, what family of organic compounds has historically been used for the creation of perfumes? So here we're looking for something that makes a smell, an odor, a scent, and that would be our esters. Okay, moving on to number 30, for the molecule above, the empirical formula, so being able to see what we have, is going to be. So in terms of carbons, you have a carbon 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 of them. And then in terms of hydrogens, if you counted how many hydrogens you have at each point, so we have 3, 2, 2, 1, 2, 2, 1, 2, 3, 1, 1, and 2. So if we placed all of our hydrogens and then just counted those numbers, you'd have 22. So if we have it in this form of how many carbons you have, how many hydrogens, and you fill in those numbers, then A and B would be 1 and 2 for the 12. C and D would be 22 for the amount of hydrogens. Number 31, which of the following statements best describes an elimination reaction? So an elimination reaction, you start with one compound and then you're taking something off that compound, forming a double bond and a small molecule. So going through that, carbon atoms in the organic product are bonded to fewer atoms than the carbon atoms in the organic reactant. That's true. We're bonded to fewer because we have a double bond being formed. And then if you look at B, that's describing substitution. C is describing addition. And D is two molecules are combined at a small, and this is describing some sort of condensation reaction with water being formed. Number 32, looking at the combustion reaction of propane. Propane is C3H8, so you could already rule out the other two. And remember, if you don't remember what propane is, now we should be able to draw it, but you could always look at your data booklet, page 4 or 5, and find it. And then if you're doing the combustion, you know you're adding in oxygen, carbon dioxide, and water. Then you just want to see which one of these is balanced correctly, and that answer would be D. Number 33, what type of reaction is shown below? So here we have reactants and two products. You can see within here that your OH and Cl are swapping places, so that would be a substitution reaction. The next one, which of the following compounds could be formed in the addition reaction of bromine and but-1-ene? If it's but-1-ene, that means the double bond was between carbon 1 and carbon 2. So if this bond breaks, it would be carbon 1 and 2 that can accept a bromine. So the only one here that would match that would be C, because bromine would be attached to carbon 1 and carbon 2. Number 35, if you had the reaction between hex-2-ene and hydrochloric acid, which of the following would be a potential product? So the fact that you have a double bond, that would mean we're going to break it. So if you did just even take a look, so carbon, 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 1, 2, 3, 4, 5, 6. If you did put a double bond between carbon 2 and 3, if this was broken, that means each of these carbons can bond to one more atom, and the atoms are going to bond to are hydrogen and chlorine. So that means we have a chlorine group on, in this case, carbon 3, but it also could have been on carbon 2 if we placed them differently, but they can't be on any other carbon other than the ones that had the double bond between them. So for me, because I'm not seeing it on carbon 3, it would have been on carbon 2, so 2-chlorohexane. Number 36, the polymerization of propene can be classified. If you are breaking a double bond in your main chain, it's going to be an elimination reaction. 37, looking at polyvinyl, wanting to know what is the monomer that was used. You can rule out B and C because we don't see a carbon bonded to an oxygen in our polymer. So now we're looking between A and C. Sorry, this should have been B and D, we're ruling out. And then because we know forming polymers, you must either break up a double bond or have a condensation reaction. We need that double bond to be there because we don't have anything for condensation, so this has to be C. Okay, so my molecules are not showing up once more. So just going through this, just understanding if you're aromatic, you need to see a benzene ring. That's one. If you're an alkane kind, you have to see a triple bond. If you're carboxylic acid, you would have to see your carbon double bonded to an oxygen, single bonded to an OH group, and then that carbon either is bonded to another hydrogen or a chain. An ester is similar to the carboxylic acid, except instead of having a hydrogen, it's connected to another chain. So sorry about that with what's happening here. And then with asking if it's soluble, if you're soluble in water, you're looking for a polar molecule, and the molecules that are polar will be the alcohols and the carboxylic acids. So that's the two we would be picking from. And this last one is referencing the bromine test. If it was added to each compound, the reddish-brown bromine color is observed to disappear in these two compounds. So this is going to be, if your color is disappearing, you want to look for the compounds with a double or a triple bond. So we're looking for that double bond or a triple bond to break, because if bromine's added to the molecule, that bromine color will go away. Sorry that wasn't showing up. That's a bit disappointing. Question 41, what compounds would you need to synthesize the following? This is an ester. The part that's single bonded to the oxygen is coming from the alcohol. So 3 carbons, and then on carbon 1 would be the alcohol group. So this would be propane 1-ol. And then the part that is containing that double bond to oxygen, that is coming from the carboxylic acid with just 1 carbon. That would be methanoic acid. So A is our best choice. Oh, and then once again, this didn't show up. So we will just skip this one over. It was just being able to identify, and we'll just move on from that. And same thing, this doesn't want to show up. This one was a boiling point question. I could probably actually draw this one quickly because it was just all line diagrams. And this last one, 2, 3, 4, 5, 6, OH, and then oops. Okay, not that. Okay, we have this, and then like that. Okay, so this one's asking about arranging in increasing order boiling point. So we would want to see, I like this question because right away, the one that has the OH group should have the highest boiling point. So we'll put that one last if this was numbered 1, 2, 3, and 4. And then the rest, because they're just all alkanes, we don't really have to worry about anything else. It's just smallest to largest. So the smaller one would be able to boil first, and then as they get bigger, then they would need more energy to boil. This is really getting frustrating for me. Okay, we'll skip this one and go down to number 45. They're just asking about products. If it's condensation polymerization, water is always going to be a product. And, oh, same thing. Okay, this one I'm just going to draw a part of it out just so we can see it. And it's asking which of the two are examples would we get, or reactions for the polymers. So the first one that we can't see, it's a carbon double bonded to an oxygen, and then to a nitrogen, and then to another chain. The second one is just all single bonds, and you have fluorines on it. So this one is just taking a look that if you have that nitrogen bonded to a carbon, double bonded to an oxygen, this is going to be an amide link. And amide links form like ester links. They form through condensation reactions. So just to be aware of that. And then the second part, if you're not finding any double bonding to an oxygen, it's not going to be an ester or an amide. So it had to have been formed from addition reactions. So this one would have been C, which I'm sorry that you can't see it. This last one on this page number 47, classifying your reactions. Just go through the ones you know. The first one, I think it's pretty obvious, is esterification, because it would be the hardest one. So the numbers are missing because of course they should be. So number 1. The second one, you're starting with one reactant and producing an alkene and water. So something was eliminated from your reactant. So that would be a number 2 for elimination. I think coming down to the third one, you have 2 reactants, 1 product, and this would have been a double bond. So we're breaking the double bond. That would be an addition reaction, which leaves the last one to be a substitution. And hopefully we can see that because a hydrogen is swapping place with one of these bromides. So the bromine is on the end, and now we have a hydrogen with bromine. Okay, number 48, matching. We have an addition reaction. Addition, you need to break a double bond. So if we had these numbered again, that would be number 2. Substitution, we want to switch some groups. And so you have 2 reactants. I probably would have saved this one to the end just for process of elimination, because hopefully we can tell number 3 is esterification, and this last one starting with just one product with single bonds and a catalyst, that's going to be elimination. So number 1 definitely sets up for substitution, but it might have also looked like an addition even though we didn't have a double bond. Anyway, I think it was just a little bit more clear once I did a process of elimination. And this last one, again, doesn't want to show up. Just going through it, if you're looking for that phenyl group, you're looking to see carbon bonded to a benzene ring. If you're looking for an ester group, you're looking for that carbon double bonded to an oxygen, single bonded to an oxygen. And then these R's represent other carbons. And a carboxyl group, you're looking for a carbon double bonded to an oxygen, single bonded to an oxygen with a hydrogen on it. And then you had that chain. So sorry that those didn't show up, but if you made it this far, thank you for watching. If you did find this helpful, please subscribe, and if there's any other video I could do for you, let me know. Also check out my website for specific videos on specific topics in chemistry. And thanks again for watching.